Hey, welcome back. I hope you're having a good week. We're going to continue where we left off in chapter 7. So, chapter 7, we're looking at finance, saving, and investment. And we said investment is generally linked to savings, right? So, the amount that is saved in the economy generally is the same amount that is basically invested, right? The amount you actually save in the bank is basically the same amount that the bank takes and gives out as a loan to someone else, okay, for an investment purpose, right? And we said investment is really important in the economy. Why? Because investment, according to economics, right? Remember, this is not investment in financial securities, but this is investment according to economics. Investment according to economics is when firms and companies and factories and producers, right, actually buy capital and they use that capital to actually produce more goods and services. Okay, so generally, the more capital firms or producers tend to have, right, the more goods and services they can produce, and the more economic growth we actually have. Okay, now where do the funds that finance investment come from? Well, to actually answer this question, we have to do a bit of math. Okay, but it's not really complicated math. I want you to follow me carefully. Okay, right now let's assume that households income is denoted as Y. Where have we seen this Y before? Well, we've seen this Y before in chapter 4. Okay, and we said this Y had to do with GDP as well. Okay, so chapter 4, we had Y, where we said Y is equal to income and Y is basically equal to GDP as well. Okay, let's assume that the average household income is denoted by Y and consumption expenditure is basically called C, and private savings is basically called S. Okay, in that sense, we can say that Y equals, okay, so the income you make should equal C, which is the amount you spend, the amount you save, and it should also equal T. And what is T? You're probably wondering to yourself. Well, T is basically what we call net taxes. Okay, so net taxes is defined as taxes paid to the government minus cash transfers received from the government. Okay, so cash transfers such as social security benefits or unemployment benefits. Okay, so the amount of income you make, right, should also be equal to the amount of expenditure you have, the amount of savings you eventually have, and the amount of taxes you basically pay out. Okay, so if you're making $30,000 a year, this $30,000 should equal how much you spend out of this $30,000. Sorry about that. Plus the amount you actually save out of this $30,000, which is your savings, plus the amount you actually pay in taxes. Okay, right. And like I said in chapter 4, we already established that GDP equals income, which also equals expenditure, right? But remember, using the expenditure approach, we said GDP equals consumption, it equals investment, it basically equals government expenditure, and it also equals X minus M, which is basically exports minus imports, which is also net exports. Okay, now we have two equations where we have Y. Well, in equation number 2, we have Y here. And equation number 1, we have Y here. Okay, so number 2 and number 1 are basically almost the same. Equation 1 and equation 2 are the same. In that sense, we can basically equate 1 and 2. Okay, and to basically give us equation 3. Okay, and to have equation 3. Okay, so this is basically equation 1. C plus S plus T is equation 1. And C plus I plus G plus X minus M is basically equation 2. And joining equation 1 and 2 together, we get equation 3, which actually makes sense, okay? Because we have Y defined here, and we have another Y defined here, okay? And the reason we're doing this, guys, is basically we're trying as macroeconomists to find what basically influences investment in the economy, okay? So at this sense, we rearrange equation 3 into equation 4 and we basically solve for I. Okay, so our main thing is to solve for I and to solve for investment. We're trying to see what investment in the economy depends on. Okay, once you actually solve for I, and it's really simple, you shouldn't freak out about it. On the test, I'm not going to ask you guys to derive equations, but once you solve for I, you will basically know what I or investment in the economy depends on, okay? So once we solve for I, we'll notice that I depends on private savings. It depends on T minus G, and T minus G is what we call government budget. Which actually makes sense, okay, because the government budget, right, involves revenue, which is basically taxes to the government, minus government expenditure, plus M minus X. And M minus X is basically imports minus exports, right? But it has to do with international borrowing. And I won't go too deep into M minus X because it has to do with open macroeconomics or international economics, okay? But know that the investment in a country, which is I, depends on savings, okay? So the more savings there are, the more there's investment. It depends on the government's budget. If the government is actually running a surplus, which is basically T minus G being positive, right, there's more investment. And if the country is able to borrow from outside, there's more investment as well, okay? Right. So equation 4 is what I want you to focus on, okay? So funds for investment, or funds that finance investment, comes from these three sources. It comes from household savings, which is S. It comes from the government budget, okay, which is T minus G. Now, if T minus G is positive, then we have what we call a government budget surplus. Now, if T minus G is negative, we have what we call a government budget deficit, okay? And currently the United States is running a deficit, meaning it's actually spending more than it's earning, okay? So then we call that a deficit, okay? If T minus G is negative. And then borrowing from the rest of the world, which has to do with imports minus exports, okay? So if your imports is higher than your exports, the country tends to borrow from the rest of the world because the country is actually purchasing foreign currency, okay? Right, so these are the three things you need to know that actually finance investment. And also one more term we need to define is basically S plus T minus G. And S plus T minus G is known as national savings, okay? So private savings, so this is savings from households or consumers, plus savings from government, okay, should equal the national savings of a country, okay? And currently the national savings, I think at the height of the COVID pandemic, was 33.7%, meaning the average American was basically saving 33.7% of their income. Right, the next thing we'll look at is financial decisions and risk, right? And the really cool thing about financial markets is that they allow us to decide when to use scarce resources, okay? So when to actually borrow or when to actually lend money. And also they allow us to manage risks that may come from these decisions, okay? But in deciding when to use money and in deciding when to use resources, right, you need to be cognizant of time, and that is where the time value of money actually comes in, right? We said finance is all about lending and borrow decisions, okay? So for example, do you spend today or do you decide to spend in the future? Should you borrow money today or maybe you should borrow money in the future? Should you get that loan for the boat today or maybe you should just wait a few months to actually get that loan, okay? Right, so in that sense, we need to look at the time value of money and we need to be conscious of money, or we need to be conscious of time, okay? How time basically influences the value of money, okay? And in that respect, we must compare the value of a dollar today versus the value of the dollar in the future, okay? So we need to look at what we call the present value and what we call the future value, okay? Right, so suppose you win a lottery and suppose you win $1 million, okay? Well, should you take the $1 million today? Or maybe should you take the $1 million in the future? Well, your answer will depend what is the value of $1 million today versus the value of $1 million in the future, okay? So to actually sort of compare the present value, which is value of money today versus value of the money in the future, we do what we call the present value formula. And the present value of a future amount is the amount that will grow to be as large as the future value when interest is basically considered. Okay, so the present value of a future amount n years in the future when the interest rate is R% equals the future amount divided by 1 plus R all to the power n. Okay, so the present value equals the future value divided by 1 plus the interest rate all to the power n. Okay, so that is how we find the present value. Okay, so let's do an example just to make this stick. Right? Suppose you want to find the present value of $200 2 years from now when the annual interest rate is 5%. In other words, how much should I invest today at the going rate of 5% to get $200 2 years from now? So how much should I put in a bank today that is paying an interest rate of 5% to actually get $200 2 years from now? Okay, so I actually use my present value formula. We know present value equals future value divided by 1 plus the interest rate all to the power n, which is basically our time period. Okay, so in that sense, we have the future value is $200 divided by 1 plus the interest rate. So that is 5%. 5% is also 5 divided by 100. So that is 0.05. All to the exponent of 2 or all to the power 2. Okay, because it's 2 years from now. So we have 200 divided by 1.05 squared, and that is going to be our present value. Okay, so I'm just going to work through that quickly because I don't have the number here. I'm just going to use my calculator quickly to just work through that. And we have 1.05 all squared, and that should give us 1.1025. Okay, so then we have 200 divided by 1.1025, and you should have 181.4. Okay, so if a bank is paying me an interest of 5%, right, an annual interest rate of 5%, and I want to make $200 2 years from now, I should deposit $181.4 into that bank. Okay, so that is basically the future value. Okay, now let's take a look at another example. What is the present value of $1,000 3 years from now when the annual interest rate is 0.65%? Okay, so we have the present value equaling $1,000 divided by 1 plus 0.65 divided by 100, which is 0.0065 3 years from now, so all to the power 3. Okay, so then we have the present value equals, so let me just work this quickly, 1 plus 0.0065 is 1.0065 all to the power 3 should be 1.039. Okay, and then we have $1,000 divided by that, and we should get $961. Okay, wait, I think my number is probably off. Just give me a sec, let me just work through this quickly. So you have 1 plus 0.06 to the power 3. Okay, and you have 1,000 divided by that. And you should get roughly $980. Okay, so if you do the math right, you should get roughly $980. Okay. Roughly around $980. Okay. Right. So basically, that's how you calculate the present value. Okay. The next thing we're going to look at is an interesting concept of which basically influences financial investments or financial decisions, right? And this is basically what we call the net present value. And the net present value involves whether or not the present value of the future income stream is greater than or less than the cost of borrowing. Okay, so suppose you have some amount, right, or you borrow some amount, right, to actually make an investment, right? Well, you need to compare the amount you're borrowing to the future income of that investment you're making, right? But to actually make a sort of good decision, you need to convert the future income into the present value, okay, and compare the cost of borrowing to the present value, okay. So let's look at an example, right? Let's say Eli is into gaming and Eli can make a game console for $500. Okay, so it cost him $500 to basically make a game console. And he can sell it after 2 years for $24.20. Okay, so in 2 years time, you're able to sell that for $24.20. And the interest rate on this borrowing is basically 10% a year. Okay, so we can actually find the present value of his income or his future income. So that is going to be $24.20. 2 years into the future, which is divided by 1 plus 0.1 to the power 2, sorry. And you should get $2,000. Okay, so to find his net present value, it's going to be his present value minus his cost. Okay, so in that case, it's going to be the $2,000 minus his cost, which is basically $500. Okay, right, so we get $1,500. Okay, so we have what we call a decision rule. So if the net present value is positive, then he should actually invest in the game, or he should actually invest in borrowing to actually make that video game. So you should absolutely do it. Okay, if the net present value is negative, then you don't do it. Okay, so that is the decision rule most financial analysts and financial investors use. If the net present value is positive, then you should absolutely take that investment decision. But if the net present value is negative, then you shouldn't take that decision. Okay, right, so what if the interest rate is 50% a year? Okay, so let's just look back at this. Okay, so we have $24.20 with the interest rates being 50% a year. So we have $24.20 divided by 1.5 to the power 2. Okay, and what do we get? So let's see this quickly. 24, so we have 1.5 all squared. You have 2.25. Okay, so 24.20 divided by 2.25, and you should get 1,075. Okay, so 1,075. Now we know his cost still remains the same, so our net present value is going to be 1,075 minus his cost, which is basically 500, and that is basically 575. Right? One thing you realize is that his net present value has actually decreased. Initially, his net present value was $1,500, but now his net present value is actually $575, and it's actually closer to zero now. Okay, it's getting close to zero. So when the interest rate increases, your net present value tends to decrease, And it's highly unlikely that you make an investment, so investment decisions tend to decrease as well. Okay, so basically there's a negative relationship between the interest rate and the net present value. Okay, there's a negative relationship between the interest rate and the net present value. Right. Now, finally, let's just go through a few definitions that actually, few definitions that actually affect financial institutions. Okay, so a financial institution's net worth, remember financial institutions make money by basically lending money out and charging interest, and they lose money if they actually have to borrow. Okay, so you depositing money into the financial institution is basically sort of like a cost to the financial institution, right? Because it basically borrows your money and lends to other people. Okay, so the net worth of a financial institution, right, is the total market value of what this financial institution has lent minus the market value of basically what it has borrowed, right? If the net worth is positive, meaning what the financial institution has lent, is basically its revenue. If it's positive, meaning the revenue is greater than what it has borrowed, which is basically its expenditure, right? We say the financial institution is solvent and can remain in business, meaning it's making more revenue, right, than it's making in expenditure. But if the net worth is negative, we say this financial institution is basically insolvent and tends to be illiquid, okay? And the financial institution will actually go out of business, okay? So that happens when its revenue, which is the total market value of what is lent, is less than its expenditure, which is the market value of what it has borrowed, okay? The financial institution tends to be insolvent and will go out of business. And this is basically what happened during the financial recession in 2007. Okay, majority of financial institutions became insolvent because the market value of what it had lent, it had really made bad loans, okay, decreased, hence less revenue, and the market value of what it had borrowed basically actually increased, okay, so more expenditure, right? So its revenue was less than its expenditure and became insolvent, and majority of financial institutions actually closed down during the financial recession of 2007. Okay, right, so this is going to end part 2 of chapter 7, and I will give you part 3 in the coming moments. Okay, thank you very much, and I really appreciate you for taking the time to actually watch this lecture video.